Hi, in this video, we're going to be doing A-level maths 9709 paper 42 in mechanics major in 2025. This paper is 1 hour 15 minutes long, so we'll try to finish within that time limit. So without further ado, let's get started. Okay, so for this first question, we're told that a crate is being pushed in a straight line along a horizontal surface by a force of magnitude 25 Newton inclined at 20 degrees above the horizontal. And we're also told that this crate moves a distance of 12 meters in 8 seconds with constant speed. Okay, so for the first question, we have to find the constant speed of the crate. All right, so okay, to find this, we're gonna have to take the v, the time, and then we take this distance over time. So very simple. So it's just 12 over 8, which should give you 1.5 meters per second. So this is the final answer for this part. Let's head on to the next part. Okay, so for the second part, we're gonna have to find the work done by the 25 Newton force. Okay, so to do this, we have to be careful. Okay, so I'm just gonna show it to you using a diagram. So we'll let this be our crate, okay? And the 25 Newton force is acting in this direction. And the distance, 12 meters, is actually talking about the horizontal distance that is covered. And for the work done formula, W equals FD, both the F, the force, and the distance, they should be in the same direction. So you cannot just multiply the 25 and 12 directly. You have to either multiply the horizontal component of the force with 12, or you find the distance that it covers in here. So yeah, all right, so we're gonna take the horizontal component. So that's just 25 cosine 20 degrees times 12. Okay, so this will give you 282 joules to 3SF. So this is our final answer for this part. Let's head on to the final part. Okay, so for here, we're gonna have to find the power at which the 25 Newton force is working. Okay, so to do this, we are gonna use the formula P equals to E over T. So where our E is the work done by the 25 Newton force and T is the time which the work is done. So we're gonna take our exact value. I'm not gonna take the rounded off value because that will affect our answer. So T is 8 seconds. And I'll just type all this into a calculator. You will get 35.2 watts to 3SF. So this is our final answer for this part as well as the entire question. Let's head on to the next question. Okay, so here we're told that two particles P and Q of masses 0.2 kg and 0.1 kg respectively are free to move in a straight line on a smooth horizontal plane. P is projected towards Q. P is projected towards Q with speed 5 meters. At the same instant, Q is projected away from P with speed 2 meters per second. When P collides with Q, the particles coalesce. So basically, this means that the particles, they join together and they become a single particle. And so we have to find the kinetic energy lost during the collision. Okay, so first let's draw a diagram to visualize what's happening here. So we're told that P, we'll let this be P, and we'll let this be Q. So at the instant, P is projected towards Q at 5 meters per second. At the same instant, Q is projected away from P. So Q is going here with speed 2 meters per second. So as you can see, they're going in the same direction. And and let's also label the masses. So this is 0.2 kg, this is 0.1 kg. And then when they collide, they combine together to form one particle of 0.3 kg. Okay, so to, to find the kinetic energy loss, we first have to find the speed when the particles coalesce. So to do that, we're going to use a conservation of momentum. So let's find the total momentum here. So to do that, we're just gonna do m1 plus v1 times m2 v2. So m1 is 0.2 kg, and then v1 is 5. m2 is 0.1 kg, and v2 is 2 meters per second. So this gives you 1.2 Newton second. So this is the total momentum. And as we know, during a collision, momentum is conserved. So now we're going to use the reverse formula of P equals mv. We'll make v the subject. So v is just P over m. And so P is 1.2 and m is the mass of the new particle, which is 0.2 plus 0.1, which is 0.3. And this would give you 4 meters per second. So this is our final speed. Okay. Now we can find the KE before and after. So let's find the KE before. So to do that, we're just going to use our formula half mv squared and add up the KEs. So half m1 v1 squared plus half m2 v2 squared. Okay, so sorry. What's going on? Okay, let's just substitute everything. So m1 is 0.2, and then v1 is 5 squared. And half m2 is 0.1. v2 is 2 squared. So this one will give you 2.7 joules. Now let's calculate the KE after. So to do that, just gonna use this formula. And don't forget to take the mass of the new particle, which is 0.3. And v squared is 4 squared. So this would give you 2.4 joules. So now we just take the difference between them to find the loss. So loss is 2.7 minus 2.4, which is 0.3 joules. So this is our final answer for this question. Let's head on to the next question. Okay, so for this question, we're told that a particle P has mass mkg. It's attached to one end of a light inextensible string of like 2.6 meters. So it's given in the diagram, and the other end of the string is attached to a fixed point on a horizontal ceiling. and the string is taut. So that means there is tension acting on the string. And we're also told that the particle is held in equilibrium by a force of magnitude 35 newtons, acting in a vertical plane which is perpendicular to the ceiling and contains the string. And we're also told that the force acts in a direction perpendicular to the string. Okay. And the tension in the string is T newtons, and the vertical distance of P from the ceiling is 2.4. So we're given all this info in the diagram, except the tension in here, which we have to label. And we have to find in either order the value of M and the value of T. Okay, so to do this question, let's first label all the forces. So since this particle is mass, obviously there's weight of mg because W equals to mg. And now, since we know that the forces are in equilibrium, we definitely know that the vertical and the horizontal forces are equal. All right, so first let's form an equation using the vertical forces. So the vertical forces I can see here is this vertical component of 35 Newton force, which is going to be 35. Okay, we'll let this angle here be theta. All right. And this one would be 90 minus theta. So this is 35 sine 90 minus theta, which is equals to 35 cosine theta. And then we also have the vertical component of the tension, which is T sine theta. Okay. All right. So let's form an equation using this. So it's just be T sine theta plus 35 cosine theta equals to mg. And let's find expressions for sine theta and cosine theta. So we can make use of these lengths that were given. So this will obviously be 2.4 meters. And using a simple trick, we can evaluate. So sine theta will just be opposite, which is 2.4 over hypotenuse, which is 2.6. So this would just give you 12 over 13. And hence cosine theta, and use your calculator to find it out. You would get 5 over 13. So let's substitute these into our formula. This is 5 over 13 times 35 equals to mg. Okay, now let's multiply the whole equation by 13 and simplify the equation. So we'll have 12t plus 35 times 5, 175 equals to 13 mg. So this is our first equation. Let's form our second equation. So to do that, we're now going to consider horizontal forces. And the only horizontal forces we can see is the horizontal component of the tension, which is T cosine theta, as well as the horizontal component of the 35 Newton force, which is 35 cosine 90 minus theta, which is equals to 35 sine theta. So we'll equate these two forces, T cosine theta equals to 35 sine theta. So let's form it. So 5 over 13 T equals to 12 over 13 times 35. And we can straight away solve for T, which would give you 84 newtons. So this is our second equation. So since we have a value of for t, we can just straight away substitute into the first equation. So yeah, so this is our t value. So 12 times 84 plus 175 equals to 13 mg. And we can straight away solve for m, which is 12 times 84 plus 175 divided by 13, divide by 10, you would get 9.1 kg. So these are our values for m and t. So these are final answers for this question. Let's head on to the next question. Okay, so here we're told that a car is traveling along a straight horizontal road, and the car passes through a point A on the road, traveling at a speed of 15 meters per second, and then accelerates uniformly at 0.4 meters per second squared for 30 seconds. The car then moves at constant speed for 3t seconds, where t is less than 30, and then the car then decelerates uniformly at 0.2 meters per second squared, and after further t seconds, passes through a point B on the road. Okay, that's a lot of information. So for the first part, on the given axis, we have to sketch a velocity time graph for the motion of the car between points A. Okay, so at t0, the car passes through point A, and at that point, the speed of the car is 15 meters. So, sorry. So this would be 15. So this is the initial speed at point A. Okay, and then after that, it accelerates uniformly at 0.4 meters per second for 30 seconds. Okay, so to find the speed after 30 seconds, we can use the formula v equals to v equals to u plus at, where u is 15, and then a is 0.4, and then t is obviously 30 seconds. You will get 27 meters per second. So, okay, since it says accelerates uniformly, the gradient would be constant, because we should know that the gradient of a velocity time graph represents the acceleration. So I'll just let my line be like this. Okay, this is good enough. And then this will obviously be 27. Okay. And then after that, the car then moves at constant speed for 3t seconds. Okay, so where t is less than 30. So that means 3t must be less than 90 seconds. Okay, it doesn't matter. Let's just draw a straight line, flat straight line, for 3t seconds. So this is 30 plus 3t. And then the car decelerates uniformly at 0.2 meters. Okay. And then after a further t seconds passes, okay, so to find the speed at point B, we'll again use this formula. So our u is 27, and our a this time is negative since we're decelerating, and then t is just t. Okay, so since t is less than 30, this would be less than 6. So our final, sorry. Okay, so this would just be 27 minus 0.2 t. Okay. So 27, 0.2 t. So 0.2t is less than 6. So hence this 27 minus 0.2t cannot be less than 21. So this would, sorry. Okay, so this would be roughly where our 27 minus 0.2t would be. Okay, so, okay, let me see whether it coincides. Yeah, okay, so this is after t seconds, so 30 plus 4t. Okay, so this is our final answer for this part of the question. Let's head on to the next part. All right, so now we're told that the distance from A to B is 2,750. And using this, we're going to find the value of t. Okay, so to find the value of t, since we're given the distance from A to B, we can use the area under the velocity time graph to find out the distance from A to B. And because you should know that the area under the velocity time graph represents the total distance traveled. Yeah, so this whole area is equal to 2,750. So let's find out the total area in terms of t. Okay, so first of all, let's find the area of this trapezium from 0 to 30. So this would just be half, half times the sum of the parallel sides. So this is 15 plus 27 times the height, which is 30. And this would be added with the area of this rectangle here, which is 27 times 3t. This width here is 3t. And then lastly, the other trapezium, that would be half times the sum of the parallel sides. So that's just oh, sorry. Oh, that's just 27 plus 27 minus 0.2t times 30 plus 4t minus 30 minus 3t, which is just t. This is equals to 2,750. And now let's simplify everything. Just type the numbers into your calculator. So this is 630, and this is 81t, and this is 27 27 minus 0.1t times t equals to 2,750. Okay, let's simplify this again further. So this is going to be 0.1t squared plus 27t plus 81t plus 630 minus 2,750. So I'm moving the distance to the other side. Okay. All right, let's now multiply by negative 1 over 10. This would be t squared minus, negative 10. Yeah, so this is 27 plus 81 times negative 10 minus 1,800t. And then this would be 630 minus 2,750 times negative 10 plus 2, 1, 200 equals to 0. So we have a quadratic equation. Let's try factorizing it, or you can also use the quadratic formula. So I got t minus 1060, or t equal is minus 20. Okay, now, so now this is t minus 1060 equals to 0. I'll get t equals to 1060. For the second one, we get t minus 20 equals to 0, and we get t equals to 20. However, we're also told at the very beginning that t is less than 30. So we're going to have to reject this ultimately. So hence, t equals to 20 is our final answer for this part. Okay, let's head on to the final part. Okay, so for this last part, we're told that the car continues its journey from the decelerating uniformly at 0.5 meters per second until it comes to rest at the point C on the car. And so now we have to find the total distance from A to C. Okay, so to do that, we already know the distance from A to B, so we just have to find the distance from B to C. So to do that, okay, what formula can we use? So it comes to rest. Oh, we can use this formula, v squared equals to u squared plus 2as to find the distance. So s is our distance, and then a is the acceleration, u is the initial speed, and v is the final speed. All right, so u is obviously the speed at b, which is 27 minus 0.2 t. Okay, so u is 27 minus 0.2. T is 20. So 0.4 times 10, which is 4, so u is 23. All right, now we are ready to solve. So this is 23 squared minus 2 times a. So a is the magnitude of the deceleration, which is 0.5. And the reason why I put a minus sign is because we are decelerating, we're not accelerating. All right. And then this would obviously be 0 squared, which is just 0. All right, let's move this s to the other side. So this is 23 squared. That is 529. This is minus s equals to 0. And hence s would just be 529 meters. So this is the distance from B to C. So now A to C, just take your distance from A to B, which is 2,750, and you add up this distance. And you'll get 3,279 meters. This is our final answer for this final part, as well as the entire question. Let's head on to the next question. So for this question, let's read the entire thing. So one end of a light inextensible string is attached to a particle A of mass 3 kg. So this particle here, and the other end is attached to a particle B of 4 kg. Oh, okay, so it's this one. And then particle A is in contact with a rough plane inclined at 30 degrees to the horizontal. So there's friction acting against particle A. And then particle B is contact with a smooth horizontal plane. So there's no friction. Particle B is not experiencing any friction. And we're also told a second light inextensible string is attached to B, and the other end is attached to particle C of mass 5 kg, which hangs vertically. So we can see this right here. And we're also told that both strings are taut, so there's tension acting in them and pass over small smooth pulleys that are fixed at the end of the horizontal plane. And the part of the string from A to the pulley is parallel of the inclined plane, and A, B, C are in the same vertical plane. And so all of this is given in the diagram. Okay, this is crucial. The system is released from rest. In the subsequent motion, C moves vertically downwards with acceleration 2 meters per second, and neither A nor B reach a pulley. So A and B, they don't touch the pulley at all, okay? So for the first part, we have to find the tensions in each of the strings. Okay, so to do this question, let's first label the forces acting. So for C, it's only the weight, so this is just 5G. And then the tension is obviously acting here. And then for B, okay, we'll let this be T1. For B, the same tension in this string be acting in the opposite direction. And then A, we've got the weight in here, 3G. And since it's also rough, there would be a friction acting in the opposite direction, which prevents it from going up. So this is friction. And then this is the normal contact force, which is perpendicular to the friction. And then obviously we have T2 acting in this direction. And then for B, T2 would be acting in this direction. All right. So now we have our forces labeled. Let's find the tensions. So let's first find T1. T1 is just equals to 5G. Wait, no, sorry. Okay, it's not in equilibrium because there's other erase. Okay, so C moves downwards when it's released. So that means we have to use Newton's second law, F equals ma. So F is the resultant force. So resultant force is just the weight minus T1. And T1 is, yeah, so T1 is equal to, okay, this is 5. And then A is given here, which is 2. So 5G is just 50 minus T1, and this is 10. Hence, T1 would just be 40 newtons. All right. Okay, now we can find T2 using the particle B. All right, so for T2, like since all the particles are connected, they will also be accelerating at 2 meters per second. So the resultant force for B would just be T1 minus T2 equals to MA. M is 4 and A is 2. So this is 4 times 2. So this is T140 minus T2 equals to 8. And hence T2 is just going to be 32 newtons. So this is our final answer for this part. Let's head on to the next part. Okay, so for this part, we have to find the coefficient of friction between A and the inclined plane. Okay, let's refer back to our label diagram for A. So as you can see, we know T2 and we can definitely find R. So let's find R first. So R would just be equal to the vertical component of the weight. So this is going to be 30. So this is just 3g cosine 30. Yep. Yeah, cosine 30. So R is equals to 3g cos 30. 3g is just 30. So 30 cosine 30, you'll get 15 square root 3 newtons. Yeah. Okay. Now let's make an equation using T2 and F. So we know that A is obviously accelerating in this direction at 2 meters per second. So again, we have to use F equals ma, which should give us T2 minus F equals to ma. M is 3. All right. It's 2. So this would give us T2 minus F equals to 6. Finally, we're going to use the formula for friction, F equals to mu R, where mu is the coefficient of friction and R is the normal force. So T2 minus mu R. So R is 15 square root 3 equals to 6. And T2 is 32. There's 32 minus 15 square root 3 mu equals to 6. 15 square root 3 mu, that is equals to 32 minus 6, which is 26. Hence, mu would just be 26 divided by 15 square root 3, which is 26 over 45 square root 3. Or you can also express it to 3SF. We'll just get, oh, wait a minute. Oh, I forgot to consider the horizontal component of the weight, which is obviously 3g sine 30. Okay, so let's rewrite this equation. Oh, okay. So this would be minus 3g sine 30 equals to ma, which is 3 times 2. And then we're going to use our F equals mu R. So this is T2. Oh, wait, sorry. T2 is 32 minus mu R. So R is 15 square root 3 mu. And then this is 3u, which is 30 times sine 30 degrees, which is 15. This is equals to 6. Okay. And then 15 square root 3 mu. This would be this would be equal to 32 minus 15 minus 6 equals to 11. Hence mu is 11 over 15 square root 3. Or you can also simplify it to 3SF, which will give you 0.423. So this is our final answer for this part. Let's head on to the next part. Okay, so for this final part, we're told that when the system has been in motion for 1.5 seconds, the string attached to A breaks. So for this, we have to find the total distance that A travels up the plane from the instant the system is released from rest to the instant that A comes to instantaneous rest. Okay, so to do this, let's first find the distance that A has traveled from the instant it was released until the string broke. So to do that, we know the string has been there for 1.5 seconds, so we can use S equals to UT plus half AT squared, where A is equals to 2, because we know that with the string, A was accelerating at 2 meters per second. So this is going to be 0 times t, that's 0. So this is just half times 2 times 1.5 seconds squared. So 1.5 seconds squared, you'll get 9/4 meters. Yeah. So this is the first distance. Now we're going to find the second part of the distance from um, from the time the string broke to the time it came to instantaneous rest. So to do that, we have to know that our T2 will no longer be there. Okay. Um, so the only forces, horizontal forces acting would be the resistive forces of the friction as well as the horizontal component of the weight. So using our F equals to ma, we can find the deceleration that A will be experiencing after that. So this would just be minus mu r, which is F, and minus 3g sine 30. And this is equals to ma. M is, let me see what m. Oh, m is 3, and A is just 8. And then minus mu r, that is 11/15 square root 3. And then r is just 15 square root 3, as we found out in this part right here. All right, and then 3g sine 3, 3g is 30, so 30 times sine 30, that's minus 15, equals to 3a. So this cancels, so now 3a would be equal to minus 11 minus 15, which is minus 26, and our deceleration would just be minus 26/3 meters per second squared. And using this, we can use the formula v squared equals to u squared plus 2as to find the distance, the remaining distance. So to find u, we need to know the initial speed that A was traveling at after the string broke. So to do that, we're going to use the v equals to u plus at formula. So u is u1 plus at. So u1 is 0, so a is 2, t is 1.5. So this is 3 meters per second. So u squared is 3 squared plus 2 times a s equals to v squared, which is 0 squared. So 2 times -26/3 is 52 minus 52s, which is 52/3s. That's equals to 9 squared, which is nothing. And hence, as the remaining distance would be 9 divided by 52/3, which is 27/52 meters. Hence, the total distance is at the two distances we found. 9 over 4 plus 27 over 52. We'll get 30, oh my gosh, 36 over 13 meters. We can also express it to 3SF, which will have you get 2.77 meters. So this is our final answer for this part C. And this was the entire question. Let's head to the next question. Okay, so for this question, we're told that a particle P moves in a straight line and passes through the point A at time t equals to 0. And we're told that the velocity v meters per second of P at time t seconds is given by this equation in terms of t, where t is between 0 and 3. And for the first part, we have to find the maximum velocity of P in the interval 0, 0 t 3. Okay, so to find it, we know that, like from pure maths, that to find like a maximum point, since it's a stationary point, you just have to make dy dx equals to 0. And similarly here, we're going to find dv dt in here. So dv dt would just be the derivative of our of our expression for v in terms of t. So this is just going to be reverse chain rule, 3 over 2 times 2t plus 1, and then minus the 1 from the power. This would give you half, and then multiply by the derivative of the inner function, which is 2. And so minus 4t. So 2's cancel out. So just be 3 over square root 2t plus 1 minus 4t. Now we're going to equate this to 0. Sorry, 2t plus 1 minus 4t equals to 0. Now let's make 4t the subject and also multiply by square root 2t plus 1 equals to 3. Now we're going to square both sides to get rid of the square root. So 4t square root, that is 16t squared, times 2t plus 1 equals to 9. And this would just give us 32t cubed plus 16t squared. This would be equals to 9. Okay. Maximum velocity. Mhm. Okay, let me see. Okay, sorry everyone. Uh, yeah, so yeah, I just realized that I expressed the derivative wrongly. So this is supposed to be 3 square root 2t plus 1 minus 4t. And now we're going to equate dv dt to 0. So this is 3 times 2t plus 1 minus 4t equals to 0. And now we'll make 4t the subject. Is 4t equals 3 times square root 2t plus 1. Now we're going to square both sides. So this is 3 squared. And then square root 2t plus 1 squared, that's just 2t plus 1. This is 16t squared equals to 9 times 2t. That's 18t. And then it says plus 9. This is 16t squared minus 18t minus 9 equals to 0. So we obtain a quadratic equation. So we're going to try factorizing it. We can use the quadratic formula. So we got 2t minus 3 times 8t plus 3 equals to 0. This is 2t minus 3 equals to 0. This is t equals to 3 over 2, or 8t plus 3 equals to 0. We'll get t equals to minus 3 over 8. And we know that t cannot be negative, so we'll reject this. So this is the time at which we can obtain the maximum velocity. So now we're just going to substitute this into our formula. So v equals to 2t plus 1, 2 times 3 over 2 plus 1, the power of 3 over 2 minus 2 times 3 over 2 squared. Yeah. So this is 3 plus 4, 3 plus 1 to the power of 3 over 2 minus 2 times 3 over 2 squared. You would get 7 over 2 meters per second. So this is our final answer for this first part. Let's head on to the next part. Okay, so for this final part, we're told that in the interval 0 to 3t, the velocity of p is always positive. So we have to find the distance of p from A at the instance when p is moving at this maximum velocity. Okay, so we have to find the distance. And since they told us the velocity is always positive, that means p is always moving in one direction. P did not change the direction. So to find the distance, we first have to obtain an expression for the distance in terms of t. So we have to find x in terms of t. And to do that, we're going to have to integrate the velocity function. So this is 2t plus 1 to the power of 3 over 2 minus 2t squared dt. So integrating this, get 2t plus 3 over 2 plus 1 is 5 over 2. And you divide 5 over 2. And then you divide by the derivative of the inner function, which is 2. So these cancel out. This will be minus the integral of 2t squared, that is 2 over 3t cubed plus c. Okay. So hence x is 2t plus 1 to the power 5 over 2 over 5 minus 2/3 t cubed plus c. And so at time t equals to 0 passes through the point A. And the distance from point A is given by x. So we can substitute x equals to 0 and t equals to 0 to find our c. So 2t1, that's 1 over 5. And then this 0, so this plus c equals to 0. Yeah, so c is going to be minus 1 over 5. Hence, x is equals to 2t plus 1 to the power of 5 over 2 over 5 minus 2/3 t cubed minus 1 over 5. Okay, so now we have our expression for x, and now we can just find the distance when p is moving at this maximum velocity by substituting the time when p is moving at this velocity. So we already found this in the previous part, 3 over 2, so we'll just substitute that in. So sub t equals to 3 over 2. You'll get x equals to 2 times 3 over 2, that's 3 plus 1 to the power of 5 over 2 divided by 5 minus 2/3 times 3 over 2 cubed minus 1 over 5. And this would just be equal to 4 to the power of 5 over 2 divided by 5 minus 2/3 times 3 over 2 cubed minus 1 over 5. So you'll get 79 over 20 meters, or in decimal, this is 3.95 meters. So this is our final answer for this final part. Let's head on to the next question. Okay, so for this last question, we're told that a particle P of mass 3 kg is projected with a speed of 8 meters per second up a line of greatest slope of a rough plane inclined at 30 degrees to the horizontal. And then we're also told that P is projected from a point A on the plane and comes to instantaneous rest at a point B on the plane. And after that, P slides back down the plane from point B. And then the coefficient of friction between P and the plane is 1/12 squared root 3. Using an energy method throughout, so we cannot find the resultant force and use it to solve this question. We have to find the speed of P at the instant it returns to A. Okay, first of all, let's draw a diagram. So the slope is 30 degrees inclined, and the particle P, let's say it's here, it's projected from here at point A. So this is 3 kg and initial speed was 8 meters per second. And since it's a rough plane, obviously it has to do work against the friction, right? And then after that, it goes at the point B where it stays instantaneously at rest, and then it comes back down again. And we have to find the speed of A after it comes back down. I mean, the speed of P after it comes back down to A. All right, so first of all, let's form an equation. So let's take the initial kinetic energy of P. So half times m times v squared. This would be converted to work done against the plane. So that would just be Fd. So F is equals to mu r. And then r is acting here. To find r, you just take the weight. So mg cosine 30. So mu is 1/12 square root 3, and then mg is 3 times 10, which is 30, and then cosine 30 is square root 3 over 2. So putting all this together, you would get 15 over 4 as your friction. So 15 over 4. And then the distance move, let's say this distance is x. So x, and then plus the GPE at B. So to find that, that's just m, which is 3. Then g, which is 10 mgh. H is the vertical distance. So that's just x sine 30. All right, so this is 15 over 4x plus 3 times 10, 3 times 10 times sine 30, which is 15x. This equals to half times 3 times 8 squared, which gives you 96. And 15 over 4 plus 15, you get 75 over 4x equals to 96. And x would be equal to 96 divided by 75 over 4, which is 128 over 25 meters. So this is the distance it travels up. Now we can, know the GPE of B. So when it comes back down, the GPE of B, which is 3 times 10 times x, which is 128 over 25 sine 30, it gets converted into the work done against the friction. The frictional force would still be the same, so 15 over 4 times x, 128 over 25. This would be plus half times m, which is 3, v squared. So this is 3 over 2 v squared plus 15 over 4, 96 over 5. This equals to 3 times 10 times 128 over 25 times sine 30, which is 384 over 5. Now 3 over 2v squared, that's equals to 384 over 5 minus 96 over 5, which is 288 over 5. This will give you v squared equals to 288 over 5 divided by 3 over 2. You'll get 192 divided by 5. And then v would just be the square root of this. This would give you 6.20 meters per second to 3 SF. And hence, this is our final answer for this question. And we've also come to the end of this paper. So I hope you found this video helpful. If you did, please make sure to like and subscribe to this channel for more future A-level maths and further maths past paper solving videos. If you have any questions or doubts or any future video ideas, feel free to leave them down in the comments below. And please share this with anyone you know who might find this useful as well. And I'll see you guys next time. Okay, thank you.